Okay, so we're gonna do a little notes on graphing parabolas. Um, so take your notebooks out and let's talk about graphing parabolas. Now we talked already about standard form, and standard form would be a parabola that's in the equation y equals ax squared plus bx plus c. A couple things about the parabola. If a is positive, it opens up. If a is negative, it opens down. Okay, so if a is positive, it opens up. If a is negative, it opens down. There's a couple other things that help you with this. If you're looking for the vertex, the x value of the vertex is found by doing x equals the opposite value of b. So if b is negative, then you'd make that positive. So the opposite value of b divided by 2a. And then to find the y value, you would just find the corresponding y value. C is the y-intercept. Remember that because a parabola is symmetrical, if we draw a parabola, remember that if you draw a parabola, that this is the vertex, and if you have a point over here, you have the same point over here. You have just the opposite x value, but the same y value. So if you find one point in a parabola, you've actually found two because of the symmetry of the parabola. Okay, I'll show you what that's like in one of the examples. So that's what we did on Monday. On Tuesday and Thursday, we talked about vertex form. Vertex form is written a little differently. Vertex form is when you have something like this. Again, the a value on this and the a value on that one, they do the same thing. They do the exact same thing in that they either tell you that the parabola opens up like the one I drew in green, or it opens down if a were negative. The vertex on this, because this is called vertex form, it actually gives you the vertex. The vertex is h comma k. That's consistent with what we did with transformations of functions, where that k moved the graph up or down, however many units. It moved it, the h would move it left or right. So quick example on that, if I gave you the equation y equals, I don't know, negative 2x plus 4 squared minus 3. If we were to look at that equation, the vertex on that equation is negative 4 comma negative 3. And this one opens down because the equation is negative. So if we, because the a value is negative. So if you were going to graph something like this one, you go negative 4, negative 3, and then you could plot some other points, but in general, it would take on that shape because that right there is the vertex. So that's vertex form. If it's written like that, it's really easy to figure out what the vertex is, and you don't even have to find the y value, you just have it all right there. The final one that we're going to talk about is intercept form. And that's if you get an equation written like this. Use different letters. That if you have an equation written something like this, so it's factored, right? I mean, so you got this form, it's factored. So we're going to have to factor. Boy, that doesn't even look like I wrote factored. So let me write that again. Okay, so it's factored. And what this gives you is it gives you the y-intercepts. Sorry, not the y-intercepts, the x-intercepts. Gives you the x-intercepts. The x-intercepts are x equals c and x equals d. That means you have the points c comma 0 and d comma 0 are two of the points that you automatically know if you have it in this form. So if you need the intercepts, remember the intercepts, the roots, the zeros, the x-intercepts are all where the graph crosses the x-axis. So it's always, that's just where the graph crosses the x-axis. So let me take you through a couple of examples and then you should be able to do the assignment. If you have something like this one, let's scroll out a little bit. I may need to scroll in depending on what I got here. So the graph of the equation, y equals negative x squared plus 2x plus 3. We're supposed to graph that on the axes. And notice that they said graph this equation. And it says I have to plot 5 points, including the roots and the vertex. So I need to know what the roots are and the vertex. Okay. Well, I can get the vertex because this is already in standard form. So I know that the vertex is going to be x equals the opposite of b divided by 2a. I already know because this a is negative, it opens down because that a is negative, because that value right there is negative. I know that it opens down. I know my vertex is then at negative 2 over negative 2, or 1. I can find the corresponding y value because I can say y is equal to negative 1 squared just by plugging it into the equation, plus 2 times 1 plus 3. So I got negative 1 plus 2 plus 3, negative 1 plus 2 plus 3. Sorry, that's a really bad writing there. Negative 1 plus 2 plus 3 is 4. So I know my vertex is at 1 comma 4. There's my vertex. Now I can get the intercepts by factoring this thing. So if I factor this thing, here's what I'm going to do with it. Because I want to pull that a out, I want to make sure that, if you look at intercept form, that a is extracted out of there. It kind of tells us what we have. So if I tells us what we're going to do with the intercept. So if I have y equals negative x, I'm just going to rewrite it down here, plus 2x plus 3. Now, I'd like to take that negative out in front. I'd like to factor that negative out. So here's what I want to do, because I want to get this into intercept form. I'm going to start by writing this and factor out a -1, because now I know exactly what a is. But if I take out a negative out of x squared, I also have to take a negative out of the other ones, which is going to change the signs on those. Now, if I look at that, I suddenly have this parabola, this quadratic, that I can factor. So I'm going to factor that, and that will get me my intercepts. Now you can factor it using the box method, or just knowing this is a pretty easy one. You just know that two numbers that multiply to get -3 but add to get -2 are x -3 and 1. So there's my factored form. What that means is right away I know my x-intercepts. Sorry. My x-intercepts are 3, 0, and -1, 0. So those are my intercepts. And now I can go ahead and start plotting this. I'll show you what I got, what all the information I got. I can plot this thing, and it says I'm supposed to find 5 points. I'll show you how to find those other 2. Okay, so let's look at the first thing. Let's plot that vertex. That vertex is at 1, 4. So 1, 4 is right up there. There's my vertex. I'll actually plot it all in red. My vertex is right up there at 1, 4. My 2 intercepts, I got 3, 0 and -1, 0. So 3, 0 is right there. -1, 0 is right there. Now the other thing that this thing actually gives me is, because that value at the end, remember that value at the end of this thing, the y-intercept is y equals 3. It's that value all the way there at the end. It's this value right there. That's the y-intercept. So that means the point 0, 3 is also on this graph. Now this is the key thing. If 0, 3 is on this graph, which is right here, in order for this parabola to be symmetrical, then this would also have to be a point right there. Now if we plot that, our parabola would then look like that. So let me scroll out all the way. What I did with this is I found the vertex. I actually found the y-intercept. I could have done that right away. And then I factored it to find the x-intercepts. And then that gave me 5 points. 5 points I got off of this thing. I got the vertex, the y-intercept, which also gave me another point because of the symmetry of it. And I got these 2 points right here. Hopefully that helps. Let's look at another one. Same kind of thing here. Plot the roots, the vertex, and 2 other points. Okay, so let's do the same kind of deal. We'll do it in a little different order, but let's find the y-intercept. The y-intercept is when y is equal to -15. That means that you got the point 0, -15. Remember that will give you another point, but we got to figure out where this is in relation to itself. So that's the y-intercept. Let's figure out what the vertex is. The vertex is x is equal to the opposite of b over 2 times a. So again, the vertex was at 1. But let's figure out what the y value for the vertex is. That would be 1 squared minus 2 times 1 minus 15. So y is equal to 1 minus 2 minus 15. So y is equal to negative 16. So we know our vertex is at 1 comma negative 16. So there's our vertex. So we're going to have to change the scale. Notice on this kind of problem, you can change the scale. So you can change what the y and the x go to. If I only go down to 10 here, I can make it go down a little further if I made it go down to negative 20, and I can change that. So play around with that, and that'll adjust your graph. Now the last thing we can do is we're going to find the intercepts. And specifically, we're going to find the x-intercepts. Okay, so we're going to find the x-intercepts. But actually, you already found the y-intercept. We're going to find the x-intercepts. We do that by factoring. So let me write this problem, then I'll blow it up, or I'll zoom in, and I'll go through this. So if I factor this, two numbers that multiply together to get negative 15, add to get negative 2, you have x minus 5, x plus 3. That means our x-intercepts are when x equals 5 and negative 3. The x-intercepts are our zeros. That's what they're called, zeros. They're also called roots. Depending on the textbook, depending on the math teacher, they're called zeros or roots. They're also the x-intercepts. So we know that we have an x-intercept at 5, 0, and we have an x-intercept at negative 3, 0. And now we can draw this parabola. We're going to have to adjust this graph. I'm going to let you do that, or let you think about what that would be. But if I adjusted this graph and I made it went all the way down to negative 20 down here, that means this would be negative 10, and so on. And so if I did that, I started plotting this. 0, negative 15 would be somewhere like right here. 1, negative 16 would be maybe right here. 5, 0, and negative 3, 0. Notice that 5, 0 is right here. Negative 3, 0 is right here. And then remember that since I have that point right there, I'm going to have another one in the exact same place, but just symmetrically over. And if I were to do that, then Delta Math would allow me to graph this. But I would have needed to adjust the scale on that. So go back and take a look at that. Notice it opens up because that a value is positive right in front of the x squared. All right, the last example we're going to do has to do with a rocket being launched from a tower, and we're going to use Desmos.com to graph. Okay, we know that this thing opens down. Well, it should open down. It's a rocket that's being launched. So the rocket goes up, and when you think about what's going to happen here, the rocket's going to is launched from a tower. So it's probably going to start up right here. It's going to get launched up from the tower. It's going to get to a top height, and then it's going to fall back down, and it's going to go to there. So this is the max the rocket reaches. And this is the time. That's in seconds. This is the height. And that is in feet. Right over here, that's where the rocket hits the ground. So from that, we can get all the information we need. If we were asked what's the maximum the rocket reaches, we could get that. If we want to know when the rocket hits the ground, we could figure out that time. So here's what we're going to do. I am going to pull this up here, and I'm going to go to Desmos. So I just typed in desmos.com, and I'm going to go to graphing calculator. And over here, I'm going to type in y equals negative 16x, and I use the little caret to get the squared, plus 168x plus 92. So look, then I get this graph right here. And you go, wow, I don't see anything. You can use this little out arrow and you can get this rocket goes really steep. Now you look at it and you go, wow, that's not really helpful. Well, we can adjust this window. We can adjust this window. Notice that if you hover over these points, it gives you those points that we're talking about. The two intercepts, the y-intercept, and the vertex. If you wanted to make it look a little better, what we could do is we could say, wow, it went all the way up to 533. So let's make our y values right here go from, maybe negative 10 so we can see the bottom of it, and let's make it go up to 600. Okay, so that's that. Now it looks really skinny. Let's adjust the left and right. Let's make our smallest x value maybe negative 5. And let's make our biggest x value 15. And now we get a really good picture of what it looks like. If we have that, suddenly we can get all the information that we need. We know the rocket actually started at a height of 92. Okay, so if I go back to my thing, this was 0.92. So the rocket started at a height of 92. That's how tall the tower was. This point right up here, 5.25, 533, that's the vertex. So that vertex is 5.25, 533, I think it was. I don't know if that was right, but let me check. Yeah, 5.25, 533, so that's the highest it got, that rocket got. And then we also know that the rocket hit the ground right over here, 11.022 and 0. So this point over here is 11.022 and 0. So when it's asking us on here, using the equation, find the time the rocket will reach its maximum, that's this value right up here, right? To the nearest hundredth of a second, it reaches its maximum at 5.25 seconds. It hits the ground at 11.022 seconds. Hopefully that helps. If you have questions, let me know.